I've already pressed it.
Okay, so we're going to look at some harder examples, particularly... Why am I still waiting for your attention, Mason and Charlie? There's two examples I want you to look at. The first one is what happens if you have a fraction in there. So for example, I might have x squared on 4 minus 9 on 16. It looks really horrendous, Bryce, but it's really not that bad.
Really not that bad.
X squared is x squared. 4 is just 2 squared, isn't it?
Yeah.
9 is what squared is 9? 3 squared. Oh. What gives 16? 4 squared.
48.
We've rewritten them all as what they are squared. All I've done is I've rewritten each number as what it is something squared. That's going to make it so much easier. Now you can do this in your head if you want. If you just do that in your head, that's fine. But if it's not something you can visualise, write it down. So this becomes x minus 2 minus 3 on 4, x on 2 plus 3 on 4. So again, it's still just the conjugates of something minus something, something plus something. It's the same idea, it's just they came from fractions. The other thing that they're trying to trick you with is they're putting a common factor in there. So for example, they might be saying 18y squared minus 50. And you look at it and you go, well, 18 doesn't have anything that it doesn't square root and 50 doesn't square root. But 18 and 50 are both divisible by 2. So if I take 2 out as a common factor, and you all do common factors at the beginning of the lesson with no issues, this would become what?
17, 38.
18 divided by 2 is what?
6. 9. I said 9.
9. Oh my goodness. What about 50 divided by 2?
10. That's 9.3. You even on 25.
25. Alright. Once you've done that, can you see now they're really nice numbers again? I know that 3 squared is 9. I know that 5 squared is 25. This 2 is just going to sit out the front. That's okay. This is going to be a 3y minus 5. And a 3y plus 5. Does that help explain some of those harder questions?
Yes.
It's going on YouTube.